In the environmental literature, sustainability is a common word that you will often hear. The idea behind sustainability is offering future generations the same level of environmental and human and material welfare as we have today. So always trying to keep in mind future generations and making sure that they have at least as good of a situation as we have now. Let's dive in. When considering sustainability, we can separate it into two different groups. Even though they have a common definition, there is the neoclassical group and the ecological standard or sustainability standard. And the big difference between these two groups is really based on how they perceive technology and how they perceive nature. Neoclassical people or neoclassical sustainability standard would say that technology, they're very optimistic about technology and that we can harvest resources now, and by the time that, like, let's say we harvest like raw materials that are non-renewable, well, we'll harvest them, and by the time we'll run out, we're going to find a substitute to it, or we're going to find an appropriate way to recycle it and extract the same resources from products we used in the past. We're going to develop different policies. Let's not leave that oil or let's not leave that raw material in the ground and to leave it for future generations. Instead, let's use it and develop technologies with it so that we can better future generations. So they believe in technology and they believe that nature is going to do well, it's going to survive. We're not going to destroy anything that's going to prevent us from kind of having the same potential in the future. Whereas ecological sustainability standard is not as optimistic about technology. As technology pessimists. They don't believe that technology will help us bring back the environment the way it is if we over harvest it or we extract all non-renewable natural resources. It's much more pessimistic on the outcome if we don't take into account the environment too much now. And they don't think that nature is as resilient. So they're much more in favor of protecting endangered species because all of these species have a certain value in the grand scheme of things in life, and all of these plant species as well. So we really have to protect everything because as soon as we disturb the balance, we might have very detrimental outcomes. So that's the big difference between the two. They both aim at offering future generations as good of a welfare in terms of material and environmental welfare as we have now, but they have a different view on technology and on nature. So even though neoclassical sustainability proponents believe in technology and believe that nature is resilient, and they believe that we can extract natural resources, there is still a few things to consider. If you have done macroeconomics in the past, you've seen that the measure of well-being or of how a society is doing, the main measure is gross domestic product. And gross domestic product is great at evaluating the value of all the products and services we produce in a given year, but it's very poor at evaluating what's going on with the environment. So a better one that neoclassicals propose is net national welfare, which is described here. So net national welfare not only takes into account GDP, but it also takes into account non-market output, which we've seen in macroeconomics. For the people who have seen it, that should always be considered, but it's hard to consider. But then it also removes externality costs, pollution abatement and cleanup costs, depreciation of created capital, and depreciation of natural capital. Because if we're taking natural capital, different minerals out of the ground and not leaving it for future generation, well, as soon as we're extracting it, we need to account for that. So even though GDP is going up, we're taking something that's taken away from future generations. So we have to kind of remove that value because then it's kind of cheating in a certain way. And when it comes to pollution abatement and cleanup costs, well, we have a situation where we have to clean up the environment, and that typically adds to GDP. Anything that's produced is added to GDP. Well, it shouldn't be added to GDP because if we would have had a clean environment, this would not have been the case. So those values of goods and services should not be included. Apart from all of that, this measure of net national welfare needs to be adjusted to reflect changes in income distribution, since sustainability requires that the typical person be no worse off. So we really have to evaluate if in this process all kind of groups in future generations do as well as other people are doing now. So if you believe that technology will overcome some of the challenges of the future and that nature is resilient, the goal of net national welfare is to set a certain amount of money aside for future generations based on what you're extracting out of the ground. Might make sense for you to extract some of your raw materials so that you can make money to develop technologies to help better future generations. But if, on the other hand, you do not believe that technology is there to save us, you are more in the ecological sustainability side of things, and we're going to look at the IPAT equation, which they focus on and which I find very interesting. I find it very interesting because when you look at this equation, it not only takes into account the idea that we need to reduce, let's say, greenhouse gases for the future. It's easy to say, well, let's reduce things by 20% and think, well, to reduce things by 20%, our cars and everything else that we use has to be 20% more efficient. Yes, but there's more to it than just that. So let's look at this equation. So the IPAT equation would say that the environmental impact depends on population, affluence, and technology. So population is the amount of people that are living. So if we treat population the same over years, yes, that's not an issue. But in reality, we know that the population is growing every year. So if we increase population by 10% and everyone consumes 10% less electricity because they have, or less energy because they have better cars and everything else, well, that kind of just cancels itself out. So we really have to take into account the negative side of an increase in population. Affluence, on the other side, is the fact that we might have a situation where we have more cars owned by a family, or we travel further distance. So even though we're only using a certain amount of gasoline to travel a certain distance, and maybe that car is now twice as efficient as old cars, if we're traveling twice the distance, we're still consuming the same amount of gasoline. So we have to consider how many kilometers are driven by a typical household, and per person, how many kilometers are driven, how much energy is used. So if everyone's consuming more because everything's becoming electronic versus many years ago when we didn't have that many electronics and there wasn't that much energy usage, well, we have to consider all that extra energy being drawn from all of these resources that didn't necessarily exist initially. And then technology is the optimistic side of things. Well, if technology improves and we could reduce the consumption per car or per computer or per other device, yes, it helps things out, but we always have to keep in mind that population is growing and probably the amount of usage that we have, the amount of cars owned and everything else is also growing. So it kind of considers all of those aspects together. And this here would be an example that starts with a certain amount of people, a certain amount of cars per person, a certain amount of tons of CO2 per car per year, which tells us how much CO2 per year we have. But if we imagine that population could rise by, let's say, 50% and affluence can more than quadruple, just to keep emissions constant, we need to have, like, there's this 50% gain by 1, so 1.5 times, and then there's this 4 times. So we'd have to have technology be 6 times more efficient than before just to maintain emission standards. So it's really important to keep all of this in mind. So even though sustainability seems like an in topic that's been picking up a lot of ground recently, this discussion's been going on for a long time. Malthus in 1798 did a study looking at the relationship between food supplies and population. His idea is that food supplies grow linearly and population grows exponentially. So even though we start from a situation where there's sufficient amount of food for everyone on this planet, over the years, every time that population grows at a faster and faster rate, at an exponential rate, and that food supplies only grows at a linear rate because technology could only bring us far enough, at some point we're going to reach this point where we're going to struggle to find enough food to feed the whole planet. And even though we can say that there's already some poverty and there's already some people having trouble to nourish themselves nicely on this planet right now, this problem is just going to get worse into the future. We've been lucky in the past through different technological improvements and different machineries to be able to harvest more and more resources over time. So it's managed to not go through that kind of tipping point where population growth surpasses the amount of food that's available for all the planet to eat. But the more and more we keep going on this trajectory, sooner or later we're going to hit this point where things are going to not go so well for population in terms of food available per person. One of the topics that we have to cover here is the precautionary principle, because it is one that you are likely going to encounter in the media. The idea behind it is that we need to be wary of getting rid of endangered species or plants because we don't know what kind of value it's going to have in the future. So the precautionary principle, even though we don't have proof of future benefits, and under the efficiency standard and cost benefit analysis, we wouldn't be able to put any value on this plant species or this animal species because it's not worthy of our value right now. The precautionary principle would say that we need to value those animal and plant species because we don't know what future value it may have. All in all, we saw two different approaches to sustainability: the neoclassical approach and the ecological approach. Both of them have for goal of making future generations just as well off as us. One of them focuses more on putting things aside, money and value aside for future generations to compensate for what we're taking away. And the other one focuses more on the idea that we're putting more and more strain on the environment. So we need to take into account how population is growing, how we're using more resources, and how we're destroying certain spaces, certain wildlife, flora, and what kind of value that might have in going into the future, or what kind of cost that might lead. So we don't want to hurt anything that we don't know what kind of impact it's going to have over time. Hope you enjoyed this video. I'll talk to you soon.